Okay, let's continue to the example of Pareto chart. Let's take a look of this question. A major DVD of the month club collected data on the reason for return shipment during a quarter, and the result are a wrong selection, 50,000 refuse, and 195k. Wrong address is 68k. Order cancel is 5k and other is 15k. Construct a Pareto diagram. Okay, after you read this question, you need to transfer all this information into the table so that you can understand what is the question asked you. Okay, reason for the return. Okay, this is a refuse, a wrong address, wrong selection, other, and order cancel. So make sure you arrange from the highest value to the lowest value. So the highest value for the amount of DVDs is for the refuse shipment, followed by wrong address 68k, followed by wrong selection 50k, followed by other is 15k, and finally is order cancel is a 5k. Total of all the return of the shipment is 333k. And for the total percentage, so how to calculate for the total percentage? You take this value. Okay, you take this value 195k divided by the total of the amount of DVDs. Then you get the total percentage is 59%. So you will do for each other return shipment. Then you get 20, 15, 5, and 2. The final sum, so sum for all total percentage should be 100%. If you get here less than 100% or more than 100%, please check back your calculation here, and also check back the arrangement of the value of this value in this column. It should be started from highest to the lowest. And then for the cumulative percentage, how to calculate for the cumulative percentage? For the first row, we just take this value, okay. After that, followed by the second row for the wrong address, you need to add the value for refuse and wrong address. Then you get here the cumulative percentage. Okay, after that, for this row number 3, so you need to add up all these 3 values: refuse, wrong address, and wrong selection. Then you get this answer. Same goes for other, and should be at the order cancel, you get 100%. So the total here and here should be 100%. After that, you can plot the graph. Okay, the perfect graph should contain, first is title. We call as a graph title. And then you should have y-axis, and then here is the x-axis. And also you need to provide the axis title for each y and x-axis. Okay. After that, you also need to provide, here we call as the secondary axis for y. And you also need to provide the title for this secondary axis. Okay. And here we call as the legend. Then you need to plot, okay, you need to plot total percentage. You need to put at the y-axis. Here is at the y-axis. And then for the x-axis, you need to put this item. Refuse, wrong address, wrong selection, others, and order cancel. Okay. For here is the cumulative percentage is the secondary y-axis. What we call a secondary? Secondary tu maksudnya yang second lah. Selalunya kita akan plot part CY yang ni sebelah kiri and then part CX. So yang ni selalunya invisible kan. So tetapi dalam case ni we have another y-axis, so we call as a secondary because here we call as a primary and here is the secondary one. Okay, secondary y-axis. So in order to get a full mark, you need to understand how to determine the total percentage and also to determine the cumulative percentage. And after that, you need to know which axis is referring to the total percentage, which axis is referring to the reason for return shipment and also for the cumulative percentage. Okay. Then you plot. So should be the trend here should be decreasing. And for the cumulative percentage, the trend should be increasing. Okay. So this is the complete Pareto diagram. The complete solution for the Pareto diagram. All these items you will get marked. So if you forget to put one of this item, your mark will be deducted. Okay. So this you can do this in the class tomorrow. And let's take a look of the control chart. Okay. Control chart. So, control chart. What's the control chart actually? Okay. So, control chart here. So, this is basically the history of the control chart. The control chart is invented by the Walter A. Shewhart, a person that also developed the cause and effect diagram. Okay. And the companies had been seeking to improve the reliability of their telephony transmission system because amplifiers and other equipment had to be buried underground. There was a stronger business need to reduce the frequency of failure and repair. And then by 1920, the engineer had already the importance of reducing variation in a manufacturing process, and they had realized that continual process adjustment in reaction to non-conformance actually increased variation and also degraded the quality. Shewhart framed the problem in terms of common and special causes. of a variation, and on 16 May 1924, he wrote an internal memo introducing the control chart as a tool for distinguish between the two. Okay, the overview of the control chart. So it always has a central line, or we call as a CL, for the average and upper line for the upper control limit, and a lower line for the lower control limit, like this. Okay, here we call as the central line. Here is the central line for upper control limit. Here is the central line for lower control limit. Okay. It is a graph used to study how a process changes over time, and these lines are determined from historical data. And data are plotted in the time order. Okay, in the time order, because here is the x-axis referring to the time. Day 1, 2, 3, 4, 5, 6, 7, 8, 9 until 9 days. So until here we just plotted until day 8. Okay. Then by comparing current data to this line, conclusion about whether the variation is consistent in control or is unpredictable, out of control, affected by special causes of variation. And this conclusion can be made based on the trend itself. Okay. So as you can see here, this is the advantages of the control chart. So we have here 3 advantages, which are we can determine whether our current process is controlled or affected by specific variation. And control chart are an outstanding technique for problem solving and the resulting quality improvement, and can save your organization time and money by predicting process performance, particularly in terms of what your customer or organization expect in your final product. And then for the disadvantages of the control chart, it required larger sample size, and if one out of control signal is identified, further investigation need to be done on the possible causes using other suitable tool, and can show possible changes that allow for preventative action. This is a method to do the drawing procedure of the control chart. So we have here step 1, step 2, step 3, step 4, and step 5. Okay. So let's take a look of this example. So you have this question. Okay, given this table in the time minutes to load an application was as a following table, and it was observed for 8 days. Okay, for 8 days, which 5 sample loading time taken for a given day. Okay. So the number of sample is 5. Let's take a look. Okay. Construct an appropriate control chart. Okay. So here it was observed 8 days and 5 sample. So we use 5 sample. Loading time taken for a given day. The question asks you to construct an appropriate control chart and to conclude your observation with evidence. So total up is 12 mark. Okay, let's take a look how to solve this type of question. Okay, you have this kind of table. Okay, I suggest you to rewrite back all the value, transfer into the table form like this. So you have here day, you have here average, and also you have here range. So you need to add another column for, here is X bar, R bar, and also column for X chart and R chart. Okay. Basically, contour chart consists of two types of chart, which we call as the R chart and also X chart. R chart will use the value of R bar, while for X chart we'll use the value of X bar. So X bar basically like this, X bar, R bar. So actually if you want to write down this formula for UCL, upper control limit, so X bar plus X bar plus A2 times R bar. Okay. Same goes for here, lower control limit. So you just substitute plus symbol with the minus symbol. Okay. After you arrange all the data in the table, then you need to calculate the value for X bar. Here, X bar. So, what is the value for X bar? So, here is the average of all this value. So, you get 10.02. So, for X bar, the average for each day is 10.02. Okay. Then, you also need to calculate for R bar. For R bar. So, to calculate for R bar, you just find the average for this value. Okay. So, here you get 1.14. Okay, to calculate the upper control limit, you need to use this formula. So, this formula you need to memorize. X bar plus A2 times R bar. And for the lower control limit, so here is for UCL. UCL, CL, here is UCLX. For L, CL, X. The formula is same, but you just substitute this plus with minus A2. So here is A2. A2 times R bar. Okay. And to calculate this upper control limit for the R chart, here is for the R chart. Here is for the R chart, here is for X chart. So for the R chart, the formula is quite different with the X chart. The formula for the R chart is U upper control limit UCL R equal to D4 times R bar. So for LCL, R chart is D3 times R bar. Okay, this is the formula. Okay, then you get this value. Okay, you get this value. And also this value. So you just take X bar plus A2. What is the value for A2? A2 is 0.373. Wait, I need to check back the... Actually, this value is I think is wrong because we have the number of sample is not 8 because 8 here is referring to the number of days. So the number of sample here should be 5. N equal to 5. So here is we need to make some correction here. So should be here 5. And here is A2. D3 is a 0. D4 is 2.114. So you just substitute here. A2 is 0.577. And then for D4 is 2.114. Enter. And here for D3, here is 0. Okay. So you will ask me, do we need to memorize all this value? No. This value I will give at the end of the question. Means that when you do the test, so at the back of the question you will see the appendix. So this value will be given as appendix at the back of the question paper. So no need to memorize. You just need to memorize this formula only. 1, 2, 3, 4 formula. And also how to insert the formula, the value into this formula. What is S bar, what is R bar. Okay. So then you need to plot the graph. Okay. Here is the graph that I plotted. Here is for the X bar. And here is, oh, sorry. So you see L, central line, lower control limit. So here. is UCL. Here is control limit, and here is lower control limit. Where is your lower control limit here? Oh, lower control limit here is 0. Here. Okay. So, to plot the control chart, you need to plot two types of control chart: X bar chart, control chart, and R bar control chart. Okay. So, this Y axis is referring to the average X. Average X. Value for average X is here. This is a Y axis versus day. Okay. And then for the this control value, this central line, you take the data from the X bar. And for the upper control limit, you take this value. And for the lower control limit, you take this value. Okay. Same goes for R bar. Also the central line, you take the value for here, R bar. For the central line, the value is referring to the R bar. Here is R bar. Here is the upper control limit and lower control limit that use this formula. D4 times R bar and D3 times R bar. Then you get this line. Okay. After that, you will see the trend of the graph. Okay. So, a complete control chart should consist of chart title, axis title for y-axis, axis title for x-axis, and you should have 4 line. So the first line, red line here, orange line here, is referring to the upper control limit, and the center one is a central line that use the average data for x, and here is lower control limit, and here is the data here. Okay. Then same goes for R bar control chart. Okay. So if you follow all this method, you will get full mark. Then the question asks you to conclude. The process is in a control because it does not exceed the upper control limit and lower control limit value for both chart. Basically, this is near to the central line. Let's see the books. What is the book says? Is it control or not? How do you know the process is control or not? Okay, analysis out of control condition. Okay, let's make an analysis of the condition. Okay, how do you know the process is out of control? Okay, the term out of control is usually thought of as being undesirable. However, there are situations where this condition is desirable. It is best to think of the term out of control as a change in the process due to an assignable cause. Okay. Okay, as you can see here, figure. Okay, a process can also be considered out of control even when the point falls inside the 3 sigma limit. Okay, let's say this situation occurs when unnatural runs or variation are present in the process. First, let's divide the control chart into 6 equal standard deviation band in the same manner as a figure 6.6-9. Okay, 6 equal lah. 1, 2, 3, 4, 5, 6 equal. It is not natural for 7 or more consecutive points to be above or below the central line as shown in figure 6.12a. Also, when 10 out of 10, 11 point or 12 out of 14 point, etc. are located on one side of the central line, it is unnatural. Okey, maksudnya kat sini dia kata kalau ada lebih daripada 5 data jauh daripada central line, jauh daripada tengah ni, so kita consider dia out of control. Okey, kita check balik betul tak jawapan saya kata benda ni adalah control. So kita double check, is it control? Betul ke control? So kita tengok dia punya data kat sini. Tak nampak, saya besarkan sikit dia punya. Okey, marker dia. Kita letak marker dia color ni bagi nampak. Okay. So, same goes for here. Okay. So, dia kata kalau 7 data tu, ada 7 point tu, dia jauh daripada control limit ni. Control limit pula. Central limit ni. So, kita consider dia sebagai, dia adalah out of control. Kalau kita tengok sini, so yang ni dekat kan. Dekat. Ni pun dekat, ni pun dekat. Kalau tengok ni yang jauh dia adalah 2 point je lah kan. So, 2 point je lah. Point ni. Dengan point ni. So, you boleh explain lah. This process is considered as a control. Is a controllable. Because only 2 point is far from the central line. Yang lain semua dekat-dekat. Okay, let's take a look for the R-bar control chart. Kita tengok ada. Dia sepatutnya point ni mesti lebih daripada 7 baru kita consider dia out of control lah kan. So, kita tengok ni. Yang ni dekat, ini dekat. 1, 2, 3, 5. 5. 1, 2, 3, 4, 5. Jauh lah. So yang ni dekat, yang ni dekat, yang ni pun masih dekat. Okay, still lagi kita kata dia adalah control. Sebab dia bukan 7 kan. Dia cakap dalam buku ni, dia kata 7. Okay, 7 lah. Kejap. 7 point in a row in zone C or beyond. Kalau macam ni, dia kata 6 point in a row steadily increasing or decreasing. 6 point lah. 1, 2, 3, 1, 2, 3, 4, 5, 6. Ya, so kalau macam ni, 2 out of 3 zone. So kalau macam ni, change or jump in a level. Kalau macam ni, kita tengok pun banyak dah. Lebih daripada 7. Kejap, kalau saya tengok sini. 1, 2, 3, 4, 5. Kalau ikut tu, dia masih lagi dia masih lagi control. Kejap, kita tengok semua data ada berapa? 1, 2, 3, 4, 5, 6, 7, 8 kan? 8 sepatutnya kalau kita kata 4 data, kita tengok bergantung pada nilai data juga tau. So sekarang kita ada berapa data ni? 1, 2, 3, 4, 5, 6, 7, 8 kan? 8 data. So kalau bahagi 2, 4 lah kan? 4 data. Kalau 4 data tu dah lebih daripada central line lah. Jauh berarti kita consider dia 50% dah kan? 50% lebih dah tak boleh. So kalau macam ni, kita kata 1, 2, 3, 4, 5. So kalau 5 tu, dia lebih dah daripada 50%. Betul? Dia lebih daripada 50%. So kita consider dia out of control yang ni. Okey, bukan 7 lah saya sorry. 7 tu maksudnya, kita kena tengok situation. Macam ni dia kata kan. Sebab dia kata sini. 6.12. Kalau macam ni pun 4 out of 5 point in a row in zone B or beyond. Yang bawah ni. 1, 2, 3, 4, 5. Yang duduk kat zone B ni. Oh, maksud dia kena bahagikan region. Kita nak tahu dia duduk di region. So macam ni, senangnya macam ni lah. Kita bahagikan. Kejap. Bahagikan macam ni. Cara yang paling senang. Okay, buat macam ni. Yang ni kita assume je, kita agakkan kan. Macam mana you nak tahu benda tu control atau tidak, you buat macam ni. Ambil pembaris panjang kan. So, then saya wakilkan yang ni yang kita bahagilah. Yang kita bahagi. kita bahagikan, kita letak dia dash. Okay. Kita bahagikan 3. Dia cakap tadi 3 kan? Dia cakap tadi 3. Try bahagikan 3 kepada region A, B and C. Kita agak je lah. Okay. Macam tu. Okay, kita ada region lah. Yang ni A, B, C and C. So, dia kata sini, so for identification purpose, the band are labeled A, B and C zone as shown in figure 6-12. So kita nak kata dia, kita boleh categorize as a natural unstable nature of variation make it possible to predict future variation. Okay, kalau macam tu, kita bahagi tadi kan. Sekejap, saya tengok. Kalau ikut ni, 1, 2, 3 lah ni. Terlebih ni. Maksudnya, macam tu. Kurang lah. 1, 2, 3. So, yang ni pun sama. Region 1. Kan. Kita ada region A, B, C. Macam dia buat tadi. Ni region. Kita kata ni region A. Di sini. A. Ini region B. Lagi. Region C. Okay. ABC. Yang ni pun bawah ni pun ABC juga. Yang ni pun ABC juga. Okay. Kan kita tengok dia duduk kat region mana kalau dia tengok tadi tu. Patutnya kita kata 4 kan. Daripada berapa sampel ni? 1, 2, 3, 4, 5, 6, 7, 8. 8 lah. 8 data ni kita kata 4. Kalau 4 tu macam ni kan. Kalau yang ni, kalau ikut kita tengok, yang ni duduk region B, jauh dah ni. 1, 2. Kalau macam consecutive tu maksudnya dia duduk, dia memang berterusan lah. Berterusan consecutive. Kalau macam ni dia tak berterusan kan. Dia tak berterusan. A, terus sini. A, sini balik. Sini dia A. Kalau macam ni kita tengok dia nak masuk ke B dah lah ni. Tengok ini. Tengok satu lagi. 3 kan. 3. So bolehlah kita kata dia still. Yang ni consecutive ni. Consecutive nampak tak? Yang ni dia duduk region B. Ni duduk region A dah ke bawah. Lepas tu dia duduk ni keluar. Yang ni tahu dia macam berterusan. Kan? Berterusan. Kalau 4 daripada 8 times so dah, ni dah 50% dah. 50% maksudnya dia dah out of control ni. Dia dah out of control. So kita kena buat macam ni baru nampak. Tengok yang ni. Yang ni pun sama. Kalau yang ni pun kita bahagi 3 juga kan. 1, 2, 3. So kita tengok. Kita tengok memang dia pun masih lagi yang ni pun out of control juga ni. Yang ni pun out of control juga. Kalau ikut ni kita tengok dia pun 1, 2, 3, 4. Still consecutive juga ni. Berterusan. Memang kita kata dia dekat dengan central line. Tapi dia masih lagi duduk di region A. Ni kan. Yang ni. Ni 1, 2, 3, 4, 5, 6. Of course yang ni lagi banyak tau. Yang ni. Yang ni berapa? 6. 6 daripada 4. Daripada 8. Kita tengok berapa persen. So yang ni of course yang ni 70%. Lagilah dia out of control. So kita ada kata yang ni adalah 1, 2, 3, 4, 5, 6. 6 6 out of 8 apa ni, 8 sampel ni kan, 8 ni kan, 8 data ni is located at the region A, B and C. And we have here at the beyond of the central line, kita cakap at the beyond of the central line, we have a 4 consecutive points that are located at region B and A. Okay, same goes for this X bar control chart. We observe that about 4 points at the region A and B. Region A and B. Also process is also considered as out of control. So let's take a look if the process is control lah. Yang ni you nampak banyak sampel kan, banyak sampel. Tetapi banyak sampel tapi you nampak ada 1, 2, 3, 4 je point yang terlalu jauh daripada central line. Yang ni pun cantik, elok je kan. Dia duduk dekat-dekat dengan central line. Mostly. Kita tengok kita punya graf ni. Kita dah lah ada sedikit je data. Ada 8 je data kan. Tapi yang jauh daripada central line tu 1, 2, 3, 4. Kalau dah 4 dah 50% dah. You kena kira by percent. Sebab tu you kena bahagikan kepada atas 3 region, bawah pun 3 region. So total up is 6 region lah kan. So kalau macam ni lagilah banyak. 1, 2, 3, 4, 5, 6. Nah, 6. 6 tu 75% dah. So lagi banyak lah kan. So maksudnya kat sini dia both is process is out of control. Okay. So yang ni kita akan buat untuk esok. And the stratification chart. Kalau stratification ni, yang ni mudah je untuk stratification. Kalau stratification ni dia adalah kejap ya. Kalau stratification, data dia macam banyak, dia classify tau. Dia classify into banyak group. Sebab kita nak tengok trend setiap group lah. Macam ni kita ada group kan. Group X1, X2, X3, X4 kan. Contohnya macam tu lah. Yang ni kita ada bilangan sampel, the number of sample. Contoh kita kata 25 sampel kan. Katalah saya buat macam ni. Okay. Number of samples. Kita ada X1. Macam tu kan. So, contohlah saya buat 1 sampai 20. Eh, 25. Kita ada 25. 1, 2, 3, 4, 5, 6, 7. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, betul. Okay, then kita buat X1 ni kan. X1 ni. You kena plot satu-satu tau. You need to plot one by one. So, maksudnya kat sini yang ni akan jadi yang ni akan jadi paksi X. Yang ni akan jadi paksi X. Yang ni akan jadi paksi X. X. Axis. Yang ni X-axis ni. Yang ni akan jadi Y-axis. Katalah kita bagi nama dia type of sample. Type dia adalah type X1, X2, X3, X4. Type dia. Okay. 81. Sorry, 83. Yang 107. 105. 8. 100. 97. 90. 93. 106. 89. 87. 97. 82. 100. 81. 98. 76. 95. 92. 92. Okay. Saya tunjuk katalah ada sampai, saya buat sampai 10 je dulu. Contoh lah kan. Saya rasa saya kena stop dulu.